Okay, we have a last presenter, Mr. Sukhee Cho. He is currently a research engineer at Hyundai Engineering and Construction in Korea. Here, his research interest includes the structural system of tall buildings, structural monitoring, and construction innovation with high technology. Please welcome Mr. Sukhee Cho.
Good afternoon, ladies and gentlemen. My name is Sukhee Cho. I'm a research engineer working at Hyundai Engineering and Construction Company. Today, my presentation is about real-time kinematic GPS monitoring system for tall buildings. In this presentation, I will briefly cover the verticality control method for high-rise building and the GPS system, RTK-GPS monitoring system, and about introduce two field test results. Verticality control in high-rise is one of important monitoring aspect in high-rise, especially during construction. Nowadays, total station, the most widely used survey equipment is total station and laser plummet. Total station you can see everywhere in construction site. This optical equipment, it can measure the certain coordinate of the target point outside of the building. It is so convenient, easy to work, but to measure as building goes high, it needs to secure some proper distance and angle to measure the point. So, go high, it is hard to measure the exact coordinates. So, in this reason, laser plummet are also used. Laser plummet are located at a certain point, reference point inside the building, usually at the bottom basement, and it shoot the laser beams to upside of the building and keep the reference point at every floors. It is also simple and easy method, but there are two problems. First, the reference point need to be moved at every 20 or 30 floors because of the precision of the laser beam. And the other thing is that the opening like this need to be opened during construction or during the measurement time. So, nowadays, the GPS system is one of practical alternative to measure this survey. This is the basic of GPS. To decide the unknown location of the point, at least 4 satellites are needed to read the data, and GPS itself have some errors. Among these errors, the critical one, the important one, especially in construction site, is the environmental error. These things are multipass and cycle slip. Multipass is reflected signal from surrounded various structures, and cycle slip is phase changes between direct and indirect signal waves. Especially in construction site, tower cranes and other frames, steels, pipes, all the things above the sky can, even the building next to can kind of obstacle for measurement. So there are 4 survey methods, for more precise. There are many kinds of GPS systems, but the basic concept is the same. We can find the location of unknown position based from the data transmit, let's say that correction data from the location, we know the exact coordinates. This is the RTK-GPS monitoring system with developed. It is composed of 5 RTK-GPS systems. One is the reference GPS outside of the building, and the other 4 GPS are on the same plane. I mean that in the same floor. So before data acquisition, first measure the relative distance of this GPS by total station, and this is used as the, let's say, exact value for this distance. And then, starting the data, during the data acquisition, we can calculate the relative distance of this GPS by calculation, and do the network adjustment method algorithm. We can minimize the distance difference between the receivers compared to the total station distance and the GPS measured distance. This is the equipment used for the GPS system. And this is the first test site. It's a building. It's a 134-meter residential building. The reference point was located at about 300 meters outside of the building. And this is the test building. Actually, the reference point, if the reference point is too far from the building, that the signals, the error could be increased. So usually the reference point is less than 1 kilometer, 1.5 kilometers. This is the GPS data we acquired. This is the 4 GPS, and this is the data. The x-axis is the y direction, and the vertical axis is the x direction. Except for GPS2, and the center is the average value. So this is that's the variation of from the average value. So this is the same plot according with the time. So the green one is the x-axis, and the purple is the y-axis, and the variation is less than 8 millimeter in all 3 GPS 1, 3, 4. But GPS 2 shows some kind of mess data. It's because of that during this period there are some kind of hardware problem. So during the data analysis, this time period was eliminated. And this is the coordinates and the standard deviation. Usually most of the data is very stable except GPS 2. This is the summarized result. This is the coordinates decided from GPS, and RGPS means after the network adjustment, so more refined data. So TS means the distance of this distance, and GPS and RGPS both show a very close value compared with total station. But RGPS a little bit improved, but actually in this case, not much difference. The second test is on the bridge pylon. It's about 270 meters and stand alone before cables are connected. So I tested on the top of the pylon. Yes, this is the side layout. The reference point is about 270 meters far from the test location. This is the GPS layout. This is the reference station, and this is the top of the pylon. Actually, at this time, the cable works are undergoing. So at the center of the pylon, tower cranes are located, and both sides, this kind of temporary steel frames are installed. The purpose of this one is to connecting the cable with the other pylons. And there are some kind of rolls of cables are located and other things. So actually, it is not sufficient area in this top of the site. So we put 4 GPS. And this is the satellite condition. Our testing period is between 11 and 12 o'clock. So during the test, about 20 to 23 satellites were counted on the sky. Our test time is about 1 hour, from 11:26 to 12:29. But most time, about 50 minutes, the data was discarded because of poor condition. Data has low quality because we guess that this is because of the multipass and cycle slip impact, because of the next of the tower crane and steel frame. So we made analysis with this 7 minutes data. The data sampling is about 1 hertz. So every per second we get our data. So after this test, what I learned is it is needed to investigate adequate time frame for observation before actual test. This is the GPS data. GPS 1, 2, 3, 4, and these things are 4. The data are scattering somewhere here. The variation is for x direction. X direction is the weak axis. It's about the variation is about 10 centimeters, and y direction it's about 4.3 to 7 centimeters. In this data includes both the fluctuation of data itself and the movement of the bridge pylon. So with the network adjustment, I will try to reduce the data fluctuation. This is the same data. It is plotted with time, and this is the before network adjustment, and this is after the adjustment. In an ideal condition, the 4 GPS move identical if the starting point is the same. But you know that there are some kind of signal always changes. So with this kind of network adjustment, we got a similar pattern to decide the location of the coordinate of the GPS. This is plotting for y direction. This is the result. L1, L2, L3, L4 are the distance. Before network adjustment, maximum the difference with the TS is about maximum is 90 millimeters, but after the tuning, we can reduce the difference about 3 or 4 millimeters. This is the finalized coordinate of the GPS location. Conclusion. We developed the RTK-GPS monitoring system. It is real-time, multi-GPS network monitoring system, and it is more convenient and accurate rather than conventional survey equipment. And we made a field test. We got a reliable observation result compared with total station, and acquired improved result by network adjustment. And we can trace building movement and finalize GPS coordinates for construction. But I think that for further application, we have to still have to minimize, reduce error factors such as multipath effect and cycle slip. And cross-check with other survey results by total station, razor plummet need to be considered together. Thank you.
Thank you, Mr. Cho. Now we will have the questions from the floor. Any questions? Okay.
Thank you very much for that. It's always interesting to see GPS being used much more in these situations. The query I do have, though, is that you had 5 GPS stations. One of the critical things when you're measuring on a structure is the relationship between your GPS on the structure and your GPS base station. The base stations, because they're lower down and generally among more buildings, vegetation, whatever, are much more sensitive to multipath effects. Was there a reason you chose to use 4 GPS units on the structure and only 1 base station, rather than improve the accuracy by using, say, 2 GPS on the structure and 3 base stations?
More base reference will increase the accuracy. But at this research, I'm more focusing on, I think that we have to compare in some cases, increasing base references and compare the results. But in this research, I was more focused on how to reduce the one receiver can kind of have fluctuation, so we can not sure which point during the time, which point is our measuring point. So using 4 GPS receiver is using some kind of technique to reduce that fluctuation. So that's the reason I use the GPS on the upper side. But
Could you use your microphone when you're answering?
But I think that your point is very helpful if we put more base reference and compare, or doing some kind of techniques to data processing, we can increase the accuracy more.
Okay, thank you. I have one question for you. So, you mentioned about the obstacles for the improving the accuracy of your GPS system. So, I think if you want to use this system for the high-rise building measurement or sensing, so if you consider more obstacles, because obstacle may consider the problems of the frequencies between the base station and another GPS node. So I just want to know what kind of obstacles did you test for preparing this, developing this system?
Well, in this case, it is difficult to find which factor can affect this obstacle can make some factors. In this test, I find that tower crane and steel and some kind of pipes, even not so high, even the next of the GPS can also make some kind of errors, but not so classified the error factors and the obstacle factors. I didn't make that.
Okay, thank you very much. Any other question? We can take one more question. No? Okay, thank you, Mr. Cho, and please give him a big hand.